Section 10.3 talks about compound interest. And so we're going to have a new formula here in 10.3. We'll get to it in a minute. Let's see. It says an investment is the use of money or capital for income or profit. In a fixed investment, the amount invested as principal may be guaranteed and the interest is computed at a fixed rate. These are savings accounts, money market deposit accounts, and certificates of deposits. And something we call a variable interest or investment, says neither the principal nor the interest is guaranteed. Things like stocks, mutual funds, so on and so forth. Okay, so here's our compound interest formula. Okay, it says compound interest formula is A equals P, and then if you notice here we have parentheses, 1 plus R over N. All of that is raised to the power N times T. Okay, it says A is the amount that is going to accumulate in the account. P is the principal. This is the amount of money that we're either borrowing or investing. R is going to be our interest rate as a decimal. Okay, we want to make sure we write it as a decimal. N is the number of compounding periods in a year. And T is going to be our time in years, okay? So let's see if we can figure out the first problem here. It says Kathy invested $3,000 in a savings account with an interest rate of 1.8% compounded monthly, okay? If Kathy makes no other deposits into this account, determine the amount in the savings account after 2 years. Okay, so I circled each of those things because those are going to be my variables. So P, the amount of money that we're investing, Kathy's putting $3,000 in her account, okay? R is going to be our interest rate. It says it's 1.8%. We got to change that to a decimal. So 0.018. N is the number of compounding periods per year. Well, it says it's being compounded monthly, and we know that there's 12 months in a year. And T is going to be our time in years, and it tells us that that was 2 years, right? Okay. So what we're trying to find now is we're looking for the amount of money in the savings account after 2 years. So one thing I want to mention, guys, this here is a straight plug and chug type of problem. Okay? All we're going to do is plug our numbers in and chug along, okay? So let's take a look here. It says P happens to be 3,000. So let's go ahead and write that in here, 3,000. Okay. 1 plus our interest rate was 0.018 divided by the number N, which was 12. All of that is raised to the power N times T. So 12 times 2. Okay. All right, I'm going to do the same thing we did before. The only thing I'm going to do right here, guys, you notice I'm copying everything down the same. Let's see. 12 times 2 is 24. Okay. Now, the reason why I'm not really doing much else here is because this is a straight plug and chug type problem. Okay. So, first thing I'm going to do, let me grab my calculator. Let's see, it should be, here we go. Okay, if you have a standard calculator, what we're going to do, let me see if we can switch it over. Whoa. Here we go. Let's go to a scientific calculator. Okay. Because this is a plug and chug type of problem, I'm going to type in exactly what I see, okay? So I'm going to be moving this around. Actually, you know what? Let me try this. Okay, yeah, this is a little bit better. So let me turn this guy on. Okay, I'm going to type in exactly as I see it. So I see 3,000 times, then I see parentheses, so I'm going to put those there. 1 plus, then I see 0.018. That number is being divided by 12. Okay. I'm going to close off my parentheses, and then that's being raised. Where's my power button? Here we go. That's being raised to the power of 24. Okay. And I'm going to hit enter. And so the amount of money that we have looks like it's $3,109.88. So 3109.88. Okay. And guys, if you want to see that on the regular calculator, we can do that as well. So So let me just move it over here, but I'll type in exactly as it was, 3,000 times parentheses 1 plus 0.018 divided by 12, close my parentheses, and then my power here is going to be this button right here, that x to the y. So I'm going to raise that. We said our power was 24. I'm going to hit equals, and if you notice, $3,001.88, right? So same exact answer. So there you go, okay? Straight plug and chug type problem, all right? The only calculation that I really did here is just multiply that n times t. All right, let's take a look at the next one here. It says calculate the interest at $3,000 at 4% compounded semi-annually for 7 years using the compound interest formula. Okay, so just like we did before, P is the amount of money that we're investing. That's $3,000. R is going to be our interest rate. 4% would be 0.04. Okay. N, remember, N is the number of times it gets compounded in a year. If it's semi-annually, that's twice a year. And my T here is going to be 7 years, all right? So again, first thing I'm going to do, I'm going to write down my formula. Okay. And then the next thing we're going to do, guys, we're going to just do a little plug and chug. So we're going to go 3,000. Okay. 1 plus my interest rate is 0.04 over 2 raised to the power n times t. So remember, we're going to take these two numbers here and we're going to multiply them. So I know that 2 times 7 is going to give me 14, okay? And again, I'm just doing that right now so that I can go ahead and do my plug and chug. All right, so let me grab my calculator again. Let me clear everything out. Okay. So let's go ahead and do it. So we're going to go 3,000 times parentheses 1 plus 0.04 divided by 2. Okay, close my parentheses. Remember, this is my exponent button right here, that x to the y, to the power of 14. So guys, one thing I want you to notice, if you look up here, it says 3,000 times 1 plus 0.04 divided by 2 raised to the power of 14. That's exactly what I have right here. I'm just typing it in directly the way it is, okay? And now when I hit equals, here we go. So we got $3,958, and if we're going to round to the nearest penny, that means 2 decimal places. That should be 44 cents, because to the right of my 3 is a 6, so I'm going to round that 4 up. So 3958.44, 3958.44, okay? Now, the question is asking us to calculate the interest, okay? This is the amount of money we have in the account after those 7 years. But think about how much money we started off with. We started off with $3,000. And that 7 years later, we have $3,958.44. So the interest that we actually accrued would just be the $958.44, right? Because we did start off with $3,000 to begin with, okay? So again, guys, all I'm doing is taking this number here and subtracting off that 3,000. That leaves us with the 958. All right, I'm going to scroll down a little further so we can take a look at the next thing we got here. And we have something called the present value formula. Okay, so it says present value formula. Here it is. It says P equals A divided by parentheses 1 plus R over N to the power NT. Okay, so taking a look at this formula. Oops, let's come back here. Okay, here's my formula. It says P is the present value, or the principal to invest now. A is the amount to be accumulated in the account, R is the interest rate as a decimal number, N is the number of compounding periods per year, and T is the time in years. Okay, so let's take a look at this first problem, see if we can't figure it out. It says Will would like his daughter to attend college in 6 years when she finishes high school. Will would also like to invest money in a certificate of deposit now to pay for his daughter's college expenses. If Will estimates he's going to need $30,000 in 6 years How much should he invest now in a CD that has a rate of 2.5% compounded quarterly? All right, so the difference between the compound interest formula and the present value formula. The compound interest formula, let me scroll back up here. Okay, the compound interest formula says you have so much money right now, how much are you going to have in 2 years? Or you have X amount of dollars right now, how much are we going to have in 7 years? The present value formula says, how much money would I have to put in the bank today so that I'll have X amount of dollars in so many years, okay? So how much do I need to put now so that I will have so much later on? Okay, that's why it's called the present value formula. How much do I have to presently have so that in the future I'll have a certain amount? Okay, so let me erase some of this stuff here. We're going to come back and we're going to do our variables, okay? Guys, I want you to notice over here, look at the variables we have. We have A, R, N, and T. Before we had P, R, N, and T, so these are the variables that I'm now going to fill in, okay? Look what it says. It says Will's going to need $30,000. So that's going to be the amount that we're going to want to have later on, okay? He's going to need it in 6 years. So I'm going to put the 6 right here. My interest rate is going to be 2.5%. So as a decimal, that's going to be 0.025. That money is going to be compounded quarterly. I want you to think about what quarterly means. Quarter is 1/4. So quarterly means 4 times in a year, okay? Not 25, people. When I say 25, it's not 25. Alrighty. So now, I'm going to do the same thing we did before. I'm going to fill in my formula, so I'm going to go ahead and write it out here first. Okay. And then we're going to go ahead and do a little plug and chug. All right. So let's see. P equals A. A in this case is 30,000. Okay. Divided by 1 plus R. R is 0.025. Divided by N, which is 4, raised to the power N times T. So remember, we're going to multiply those two numbers together. 4 times 6 is going to give me 24, right? Okay. So, just like we did before, guys, this is a straight plug and chug type problem. Okay, let me clear this out. I'm going to type it in exactly as I see it. So 30,000 divided by, look what we have. We have parentheses, so let's use parentheses. 1 plus 0.025 divided by 4, close my parentheses, and I'm going to raise that, again, that's my exponent button, to the power of 24. I'm going to hit equals, and the amount of money that we're going to need today is $25,833, and if I'm going to round this to the nearest penny, guys, because to the right of that 9 is a 5, it's going to bump that up, so that 29 is going to become a 30. So 25,833.30. So 25,833.30. So we're going to need $25,833.30 today, so that in 6 years we'll have exactly 30. Okay. All right, let me scroll down, okay, and it says, for the next problem, it says, use the present value formula to determine the amount to be invested now or the present value needed. So let's take a look. It says the desired accumulated amount is $45,000 after 10 years, invested in an account with 3.6% interest compounded monthly. All right, so first thing I'm going to do, I'm going to write down my formula. So it's P equals A, 1 plus R over N to the power N times T. Okay, so now let's just fill in our blanks. A, we want to have a total of 45,000. Okay. R, my interest rate is 3.6%, so as a decimal, 0.036. Okay. And compounded monthly, well, there's 12 months in a year. T is my time in years. That's going to be 10. Okay. So just like we did before, I'm going to fill in my blanks. We want to have 45,000. Okay. 1 plus 0.036 over 12 raised to the power. Remember what we're going to do with these numbers. We're going to multiply them. So 12 times 10 should give me 120. Just like we did before, I'm going to grab my calculator right here. Let me clear this out. So let's type in exactly as we see it. 45,000 divided by, remember, we got to do the parentheses. 1 plus 0.036 divided by 12. Close my parentheses. And we're going to raise that to the power of 120. And I'm going to hit equals. And so today, we're going to need $31,412.36. So 31,412.36. 31,412, oops. 412.36. This is how much money we need to put in the bank today so that in 10 years we'll have 45,000, okay? So what I want you to realize about the present value formula, the amount that we're going to get is going to be less than what we want to have, right? Because that would make sense. How much money do I have now so that later on I'm going to have more? So this number here is always going to be smaller than that one there. Okay? With the compound interest formula, it works the other way around. The amount of money that I have right now is going to be smaller than how much I'm going to end up with in 5 years, 15 years, 20 years, whatever it happens to be, okay? Let's take a look. Another problem, almost identical. It says the desired amount is $100,000, okay? So I'm going to write this down. A, it's going to be 100 grand. Let's see, our interest rate is 4%, so that's 0.04. Okay. It says it's compounded quarterly, so again, N is 4. And my time in years is going to be 4 years. Okay. So again, I'm going to write out my formula. And I'm just going to do a little plug and chug here, okay? So I'm going to write 100 grand. 1 plus 0.04 divided by 4 raised to the power. Remember, we're going to multiply those two numbers together. That's going to give me a 16. Okay. So one thing I know, guys, because this is the present value, meaning how much money do I have to have today so that in 4 years I have 100 grand? It's got to be less than 100 grand, right? So let me grab my calculator again. Let me clear everything out here. So 100,000. Okay, divided by my parentheses, 1 plus 0.04 divided by 4, close that off, and let's see, raise it to the power of 16, and hit equals, and again, we said it's going to be less than 100 grand, and it's $85,282.13, so 85. 282 and 13 cents. So I hope that as we're going through these problems here, maybe they look a little intimidating at first because it's a formula that maybe we haven't seen, but as you're going through them, you can see it's a straight plug and chug type problem. Guys, your calculator is going to be your best friend. You want to make sure that you do have a scientific calculator, if not one of these, like a graphing calculator. When you come down to take your midterm and your final exam, you definitely want to pick something like this up. Let me see. Give me 1 second so I can show you guys. Let's see. Here we go. Scientific calculator. I'm going to go shopping. All right. So, guys, you definitely don't want to spend something like $121, okay? I would say something like this is perfect. Between this one here and this one here, my recommendation would be spend the extra $5 simply for the reason this one here has a display like what we have right here, okay? This one does not have that display. Here on this kind of a calculator, you're going to see that entire display right there. It's going to be, I think it's helpful, okay? There's another one from Casio. Let me see if I can find it. Here we go. This is another one. You don't have to get pink if you don't like pink, but you know, I'd rather have a pink calculator. Also, this thing here has a very good display as well. Honestly, guys, between this guy, I'm sorry, this one here and the Casio, I'd probably go with the Casio. That would be my recommendation. Again, I would avoid, you know, something like this because, look, it's about a $3 difference, and this is just going to be much easier to use, okay? So anyway, you definitely want to get a calculator. If you are interested in purchasing something like this, my recommendation is go to Marketplace on Facebook or go to Craigslist, go to a pawn shop. You know, there's a bunch of apps like Let It Go or Let Go or whatever it's called. Let It Go. Anyway, you want to get something like that, guys. This is definitely, you know, easy to use. But again, I wouldn't recommend spending $100 for it because it's just, that's a lot of money, okay? All right, let's take a look at the next problem. Now, for these problems here, guys, we're going to have to figure out, are we going to be using the present value formula, or are we going to use the compound interest formula, okay? So let's take a look at this problem here. Contest winnings. It says Mary wins $2,500 in a singing contest, and she invests the money in a 4-year CD that pays 3% interest, compounded monthly. How much money will Mary receive when she redeems the CD at the end of the 4 years? Okay, I'm going to underline this sentence right here because that's going to tell me, excuse me, which one of those two formulas I'm going to want to use. It says, how much money will Mary receive when she redeems that CD at the end of 4 years? We want to know how much she's going to have later on. We know how much she currently has. She currently has $2,500. So we're going to figure out how much she's going to have in 4 years. We're going to be using the compound interest formula, okay? So let me scroll back down here. Okay, so let's figure out what we know. We know that she currently has $2,500. Her interest rate is 3%, so as a decimal, it's 0.03. This is being compounded monthly, so that's going to be 12. And she's going to redeem this in 4 years. Okay. So guys, I'm going to write down the formula again. And we'll go ahead and do our little plug and chug business. So 2,500. 1 plus our interest rate is 3%, so 0.03, divided by n, which is 12, raised to the power. Remember, we're going to multiply those numbers right there. That's going to give me 48. Okay, so guys, because we currently have $2,500, at the end of 4 years, we should end up with more because we're putting that money in the bank, all right? So let me grab my calculator right here. Let's clear it out. 2,500 times, parentheses, 1 plus 0.03 divided by 12. Close my parentheses. Raise it to my power of 48. It equals, and there we go. We have more money. So not a whole lot more money, but we got more money. $2,818.32. So 28.18 and 32 cents, right? That's how much Mary's going to have at the end of those 4 years. Okay, let's take a look. Next problem here. Let's see, house down payment. Karen invested $10,000 in a money market account with an interest rate of 1.75% compounded annually. 5 years later, she took out or withdrew the full amount to put toward the down payment of her new house. How much did she withdraw? Again, I'm going to use the same formula that we did before. I'm still going to use my, get my pen going again, my compound interest formula. Okay. So the amount of money that Karen invested was 10 grand. Okay. Our interest rate was 1.75%, so 0.0175, compounded semi-annually. Okay, semi-annually means 2. In our time, it says that she withdrew that amount 5 years later, right? Alrighty, let's go ahead and plug and chug. So 10,000, 1 plus 0.0175. Let's see, over n, which we said was 2. Remember, we're going to multiply these numbers right here. That should give me 10. Okay. So guys, again, the amount of money she withdrew should be more than 10,000. So let me go ahead and grab my calculator again. Let me clear it out. So 10,000 times parentheses 1 plus 0.0175 divided by 2, close it off, raise it to the power of 10, and hit equals. And so she withdrew $10,910.27. So 10,910.27. See, I remember that. 10,910.27. So $10,910.27, right? There we go. Okay, I'm going to scroll down to the next one here, see if we can't figure this one out. It says, personal loan. Brent borrowed $3,000 from his brother Dave. He agreed to repay the money at the end of the 2 years, giving Dave the same amount of interest that he would have received if the money had been invested at 1.75% compounded quarterly. How much did Brent repay his brother? Okay, same thing here. This problem, they just make it a little bit more difficult by giving you a whole bunch of comparisons, but we're going to use the same formula, okay? I'm going to explain why right now. Okay, so we know how much he borrowed. He borrowed $3,000. And it says the interest rate was 1.75%. So as a decimal, okay? And it tells me that it was compounded quarterly, which is 4. And he repaid them after a 2-year period. So we want to know how much did he repay him. So we know he borrowed $3,000, but his brother charged him interest. Way to go, Dave. Just lend your brother the money. All right, his brother charged him interest. So we know that Brent's going to pay more than the $3,000, right? Okay, so let's go ahead and do this. $3,000. 1 plus, let's see, 0.0175 over 4. Again, remember, guys, we're going to multiply these two numbers. That should give me an 8. Okay, so let me grab my calculator again. So 3,000. Oops, too many. There we go. Times parentheses 1 plus 0.0175 divided by 4. Close that off right there. And raise it to the power of 8. So again, we know he paid his brother more than $3,000. How much did he pay him? He paid him $3,106.62. All right, 3106.62. 3106.62 is what Brent paid his brother back. Okay. Oh, let's see here. All right. So the last problem we have here out of 10.3, I think it's the last problem, says a new water tower. It says the village of Keeler recently completed the construction of a new water tower. The entire cost of the water tower was $925,000. I'm going to highlight that right there. It says the state paid $370,000 of that through the awarding of a grant. It says, in addition, the village can delay. They can delay paying the balance on the cost for 30 years without paying any interest during those 30 years. To finance the balance, the village board will at this time assess its 598 owners a one-time flat fee, surcharge, and then invest this money in a 30-year CD paying 7.5% compounded monthly. Okay, so let's see if we can figure this out. We're going to go through it piece at a time. The water tower cost $925,000, but they got a grant for $370,000. look at the question for part A. It says, what's the balance due on the water tower? Well, we know what the balance is going to be. We're going to subtract those two numbers, right? So we have 925, and we're going to subtract off 370,000. That means we're going to be left with 555,000. That's how much they still owe. So 555,000. Okay, now I'm going to look at this part of the question right here. How much will the village of Keeler need to invest at this time? Guys, think about at this time. That's the present. That's the present value. Okay, that's telling me the formula I'm going to use. How much do we have to have now to raise the balance that's going to be due in 30 years? Because remember, this amount right here is going to be due 30 years from now, right? They say you got to pay off that 555,000. You got to pay it in 30 years from today. So we went and figure out how much do we need to have now. Okay, so that's what we're going to do. So guys, I'm going to kind of scroll down here so that I have a little bit of room. Okay. I'm going to write down my formula. Let me write it down over here. P equals A divided by 1 plus R over N to the power N times T. Okay, so the amount of money that we want to have in 30 years is 555,000. Okay. 1 plus, let's see if we can figure out some of these numbers now. The interest rate, 7.5%. So remember, as a decimal, 0.075. And the number of times it gets compounded in a year, that's monthly. That's 12. Okay. So guys, let me write it up here. We said that R was 0.075. We said that N was 12. Remember, my T is going to be 30 years. Remember, we're going to multiply those numbers together. That's going to give me 360. Okay. So let me do it on this calculator just because. Clear it out. Move it over. Okay. So I'm going to take 555,000, okay, divided by parentheses 1 plus 0.075 divided by 12, close my parentheses, raise it to the power 360. Okay. So look how much money we're going to need today. We're going to need $58,907.61. So let me write that down. 58,907.61. Let me scroll. Here we go. 58,907.61. Okay. This is the amount of money that we need today. Remember what I said earlier, the present value is always going to be smaller than the amount of money that we want to end up with. So look, if we have $58,907.61, in 30 years, we're going to have $555,000, right? It's a lot more money. Okay, there's our answer for part B. For part C, it says, how much should each homeowner pay as a surcharge? So let's go back and take a look at the problem. We know that as a total right now, the whole village has to come up with $58,907.61. If you notice, there's 598 homeowners that live in this village. All we're going to do is take this number and divide it by the 598. So let me grab my calculator again. Take that number, divide it by, what do we say, 598. And so today, everybody needs to have $98.51 $98.51, and we're going to have water for the rest of our time, right? So let me see. I'm going to make sure. We do have one more problem. Okay, let's do one more problem here out of 10.3, and then we'll be done. Okay, so it says, you're given a choice of taking the simple interest on $100,000 invested for 4 years at a rate of 5%, or the interest on $100,000 invested for 4 years at an interest rate of 5% compounded daily. Which would you select? Explain your answer and give the difference in the two investments. Okie dokie. Okay, so look at the first one. simple interest. Okay, guys, so simple interest, if you remember from 10.2, I equals P times R times T. Okay. Simple interest. They got $100,000. Okay. Interest rate is 5%, 0.05. Okay, for 4 years, times 4. So let me grab my calculator and let's do that real quick. So clear that out. 100 grand. There we go. Times 0.05 times 4 gives me $20,000. Okay, so there we go. So we're going to end up with $20,000, right? Okay. Now, the second part says we can do a compound interest. So I'm going to do my compound interest formula. P 1 plus R over N to my power N times T. Okay. So we still have 100 grand. We're still at 5%. But if it says compounded daily, 365 days in a year, right? You know what? It's not telling me. Let's go with 365. You know what? Let's go with 360 just to see, because of the that banker's rule that we were using before. Let's go with 360. Okay, and then N times T. So my T here was still 4 years. So I'm going to change that to 360. So let me take my calculator real quick. What's 36 times 4? 360. Oops. 360 times 4 gives me 1440. Okay. All right. So let me do this again. Clear it out. Okay, 100 grand times parentheses 1 plus 0.05 divided by 360. Close my parentheses. Raise it to the power of 1440. Oops. There we go. Okay, and so I'm coming up with $122,138.58. So let me write that number down. 122,138.58. 122. Oh, I already forgot it. 138.58. 38.58. Okay. All right. But remember, we started off with 100 grand. So the amount of this is actually interest is going to be 22 grand, $138.58. Okay. So guys, just a real quick heads up. The reason I used the 360 was because of that banker's rule we did in 10.2. I don't remember if it asks. I'm guessing it's going to ask you to do that, but if it doesn't come out right, then go with 365. But that's sort of the idea. Okay, so which one would we rather have? Well, we'd rather have this one. Why would we rather have this one? And it says, look, give the difference in the two investments. The difference means we're going to subtract. Meaning if we take this number here and we subtract off that number there, wouldn't we have a difference of $2,138.58? So we want to go with the compound interest because we end up getting another $2,138.58 more, right? So it makes more sense to go with that one. All right, and that is 10.3.